Welcome back. This is an Aleks homework video on determining the strength of acids from a sketch. All right, well, these sketches sometimes are tricky. They've fooled me more than once. But really what you're doing is you're looking at a sample that's in equilibrium. So you're going to have some starting acid, you're going to have some hydronium that it makes, you're going to have some conjugate base, and then whatever water that it's dissolved in. And you're looking at it and from it determining essentially what your K sub A is. How big of a number are you getting as a fraction if you do the K sub A expression, and then whatever is the biggest number will be your strongest acid. So I would start with just a generic formula here, chemical reaction. You've got HA, which H is an acid. It's the hydrogen that's going to be donated from that acid, and then water, and then it creates hydronium, H3O, plus, and then the conjugate base. So that A is just generic for whatever H something, HCl, H2SO4, any kind of acid. The leftover is the A minus. So here's the pictures they give you. The 2-part one, HA, is your original acid. The 1-part one would be your conjugate base, and the 4-part one is the hydronium, and then water is the oxygen and 2 hydrogens. So those are the things you're looking for, and you're simply going to put them into the expression, the K sub A expression, and see which one has a bigger number. So here's the K sub A. It's hydronium times conjugate base, or the 4-part times the 1-part divided by the 2-part. That's what you're looking for. Essentially pictures that you're going to fill in these numbers. And remember that the bigger the K sub A, the stronger the acid. And if there is no K sub A, if there's no one piece at all in your picture, then what's happened is that was a strong acid and it completely dissociated and there's no remaining acid. It went completely to hydronium and conjugate base. So if you find one like that, it will be your lowest number. It'll be your strongest acid. Okay, so let's look at the first one. I'm just going to scribble out the waters. Okay, so I've got water, 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 water. I'm just going to scribble them out because I don't want them. And then what do I have? I've got 3 hydroniums. Okay, so this is 3 hydroniums. I've got 3 of the conjugate acids. And I've got 1 of the original acids. So that's 3 times 3 divided by 1. So this is a total of 9. Okay. The second one, if I scribble out the waters, I've got 1 of the hydroniums. I've got 1 of the conjugate bases, and I have 6 original acids. So this is going to be 1 over 6. That's a low number here. Okay. The next one, I'm going to have 4 of the hydroniums. I'm going to have 4 of the, 4 of the little green ones, so 4 of the conjugate bases divided by 2. So 16 divided by 2 is 8. And then the last one, I see no acids. So I'm going to have, I would have 2 hydroniums, I would have 2 of the conjugates, and then divided by 0. So this one's going to be 0. So this is going to be the strongest acid. Okay. Then the next highest number is a 9, so this would be a 2. Then the next highest number is an 8, so that's a 3. And then the final one is a 1/6. That's a 4. So I hope that helps.